guys, hi everyone, welcome to Easy Tech. In the previous lecture, we have seen how the voltage is induced in a self-excited DC generator and what is critical speed and critical field resistance. Now, in this lecture, we will solve the most important problems and the most repetitive problems in examinations, in university examinations. What are the steps to draw the O.C.C curve and to find out the critical field resistance and critical speed? Let us see. The first step is draw a O.C.C curve as per given data. This O.C.C curve is between EG versus IF, and then draw a tangential line to the O.C.C curve. And the third point, so what is the third point? The third point is draw a field resistance line, then find out the critical speed and critical field resistance for a particular value of field current and based on given data. So based on given data, based on given data. See, if you observe this problem, the field current is 0.25 and the generated EMF is 36. Now I will draw here. So this is 0. I am taking the scale is 30, 60, 90, 120, 150, 180, 210, 240 and 270. This is on y-axis. The y-axis I am taking the voltage. So one y-axis, 1 unit is equal to 30 volts. On x-axis I am taking the field current, that is in amperes. On y-axis I am taking voltage. This is called the generated voltage. And on x-axis I will take like this 0.5. So 1.0 and 1.5 and 2.0, 2.5, 3 and 3.5, and the last one is 4. So for a 0.25 amperes, the generated voltage is 36. See, one division is 30 and half of the division is only 15, right? Yes or no? This length will be 30 and this length is 15 only, and each one is 3, like that. 0.3 at 0.3, sorry, at 0.25, 36. This is 0.25. So 30, 33 and 36. The second one is 36. At 1, if you observe at 1, so the value is 138. So this is 120 plus 15, 1, yes, 135 and 138. And at 0.5, the value is 72. So 60, 75, and this one is 72. At 1.5, the value of the generated EMF is 188. So 180, 183, 186 and 188. At 2.0, yes, at 2.0, the value is 225. 210 plus, yes, this one is 225. And at 3 amperes, the value is 270. So this is 270. If you join all the lines, then I will get the O.C.C curve. So this is called the O.C.C curve. So O.C.C at What is the speed he has given? The speed is given as 1000 rpm. So this value OCC at 1000 rpm. Okay, in the question is clearly mentioned that the question is clearly mentioned at 240 volts on no load, the value of field resistance is how much? So for that, first one is draw a OCC curve. Yes, OCC curve is completed. And the next one, you can draw a tangential line to this one. So by taking a scale, you can draw a tangential line. And one more line at 240 volts, project on the OCC curve. It will touches the point at this position, at this position. So then you can project horizontally line, then I am get it as this line. You can project the line vertically. I will exactly get the value of field current is 2.25 amperes with a generated EMF of 240 volts, with a generated EMF of 240 volts. And if you want to find out the RSH value, E naught divided by IF, that should be equal to E naught divided by IF, that should be equal to 240 by 2.25, that should be equal to 106.67 ohms. And one more line you should draw. So at this point, okay, you draw a field resistance line to touches this point. Why? Because he is asking at 240 volts. At 240 volts, project the line on OCC curve, and it will touches the on OCC curve. And in order to get the field resistance line, this is our field resistance line to touches this line OCC curve, and this point is called the EA. This point is called the EA. So at any field current means at 1 ampere, I am project the line here, project on this. The point on the tangential line is S. The point on the field resistance line is T. The point on x-axis is R. Now, how can you find the critical field resistance? How can you find the critical field resistance? So RT by RS is equal to critical speed divided by N1, where NC is equal to N1 is 1000 rpm, and now RT is, if you go for the RT is 90 divided by RS. So if you draw the exactly, RS is equal to 159. Yes or no? That should be equal to 153 only. So 153. Then what is answer you are getting? That is your critical speed. Okay. So thank you guys. If you understand this problem, I will be very very happy. Once again, I am explaining here. First, based on the given data, draw a OCC curve. Take y-axis, the voltage on y-axis, current and x-axis, field current and x-axis, and then join the points, then you will get the OCC curve. After that, draw a tangential line to the OCC curve of, and at 240 is asking the field current is, I am getting 2.25. What is asking the field shunt field resistance is how much? E naught by F is equal to, I got it as 106.67 ohms, and draw a line which touches this A point. This line is called the field resistance line. At 1 ampere you will project on y axis RT, and the point which is on the tangential line is S, or T by RS into uh, RT by RS is equal to NC divided by N1. So I will get it as 153 into almost it is 16 153 into 6 times like that, almost. So I mean 6.7 like that, and 90 into 6.7, you may get more than 650, more than 650 rpm. So guys, I don't have calci now, so calculate the value so in your calci. Okay, going to the next problem. The open circuit characteristics of a DC shunt generator at 800 rpm gives the field current is 0. Yes or no? The field current is 0. The generated EMF is 10 volts. At zero point 0.5 the value is 50, and like that. I am drawing the curve. I am drawing the curve. So this is uh, O.C.C curve. This line is called the O.C.C curve. This line is called the open circuit characteristics curve at 800 rpm. At 800 rpm, and this is the line. You can observe initially at 0 amperes. At 0 amperes, some voltage will be there. Yes, some voltage will be there. That voltage is called the residual voltage. What is this voltage? So what is this voltage is called the residual voltage. So after that, you can draw a tangential line. This is our tangential line to the O.C.C curve. This is a tangential line to the O.C.C curve. So, and the fine, what is this point which is touches the line for 75 ohms? Find graphically critical field resistance of shunt field circuit if the field circuit resistance is 75 ohms. Field resistance is 75. So you should take the line, suppose at 3 amperes. So 3 amperes, if I am getting 75, 3 into 75, so 5 3 5s are 15, 3 7s are 21, 225 volts. Yes or no? Check that. At 3 amperes the voltage value is 225. Like that you will draw a field resistance line. So at 2 amperes, so I am getting 1 point. At 2 amperes, 2 into 75, that should be equal to 150 volts. So at 2 amperes, check that this value is C 150. This, and at 1.5 amperes, that's 1.5 into 75. So 75 into 15. So 5 5 is 5 7 is 35, 375, and 15. So 5 7 5 4 is 2, 525. So 520, that means 52.5. 1.5. So at 1.5 you will get this value here. Okay, 75 into 15. Okay, 5 5 is 25, 5 7 is so 75. Sorry, it is not 15, it is a 75. So 5 2 8 11 11 112.5. So that's why at 1.5 the value is 112.5. At 1 ampere 75 volts. So if you add all these points from the origin, then you will get this field resistance line. What will be the critical speed for the machine to build up? He is asking like that. So I am taking the points here. If the O.C.C curve is tangential to the tangential to this field resistance line, then that is called the critical speed, and the generator EMF is also at this position. We have to find out. We have to find out. So I am taking the points at A. Okay, what is the slope of the tangential line? So if you want to find out the slope of the tangential line is equal to CD by AB. So CD divided by AB. As this is at A you can project on tangential line. At B also you can project on tangential line. This is called the E2 minus E1, and this one is IF2 and IF1, these values. So then you will get 54. Let us check it. This value is the difference between these two is this is at 150 and 175. Yes, this is 175, and this one is how much we are getting, 190 and 105. So 105, and you will get 110 like that. Okay, so approximately it is 120, so that should be equal to 55 or 54. So I get it as 54 AB value. So the difference between these two is 0.5. So the resistance value is the slope of the tangential line, the slope of tangential line is 108 ohms, and this 108 ohms is the critical field resistance. I have calculated the critical field resistance. Okay, so how we can calculate the critical speed? So at R you can project, this is R T on the field resistance line, S on the tangential line, RT. So RT length is 180, RT length is 180, and RS length is 270. RS length is 270. Now you can find the value. So NC is equal to RT by RS into N. So RT, I am getting the value is 180, or yes, sorry, it is not 180, 198. It is 198. So this one is 198. The value is 198, and this value is 270. Yes, 198 by 270 into 800, I got it as 586.67 rpm. So this is how we can find the critical field resistance and critical speed. So once again, you will see, first draw a OCC curve, after that draw a tangential line. After that, how can you find the field resistance line? He has given this point is 75 ohms. Check that at final point. So how we are getting the 75? So if you take it 3 into 75, that should be equal to 225, and 2 at 2 amperes, 2 into 715, and 2 into 150 as 150 volts at 1.5 is 1.5 into 7, then 112.5. This value is 112.5. So after that, find the slope of the tangential line, then you will get the critical field resistance. After that, you can take at any field current, project on the y-axis the touching point on the oh, field resistance line, and one more point is also you have taken on the tangential line the length of RT and length of RS, you should note down, and RT by RS into speed, that should be equal to 586.67. Once again, listen students. See, first of all, draw a O.C.C curve, yes, and next the tangential line. After the field resistance line, if there any data is given, so if you want to find out the at 240 volts, project on O.C.C curve, then you should project on x-axis, then you will get the field current, and draw a line which is touches this point, then you will get the field resistance line. After that you can calculate the critical field resistance and critical speed. And thank you guys, and we'll see in the next lecture.